the electrons, the scattered electrons after reflection will be rearranged in such a way that it will be showing you the magnified image of the object. This is how the working principle of both the SEM and the TEM. Those we can see them later now here. Okay, in this SEM, scanning electron microscope, please do not get confused with a scanning electron microscope and the transmitted electron microscope. Do not get confused. Okay, you should not get confused with them. And you can see here in the scanning electron microscope, the specimen will be kept here. And the transmitted electron microscope, somewhere the specimen will be kept here. You can see this is a sample. The electron run from the cathode at threshold temperature. The electrons will be liberated and they will be moving towards this sample. And you can see that the the condenser lens, the primary condenser lens and secondary condenser lens and the final lens aperture and the deflection coils, all these will be arranged in such a way that so that the electrons which are liberated from the electron gun should not be scattered here, that they should be focused and directed towards the specimen only, so that there will not be loss of the electrons. At the same time, to have the effective output, the electrons which are liberated from this electron gun should be attracted towards the specimen, and so that the more and more space is covered with the electrons, the more and the more information we can get from the specimen. That is the objective of this. Okay, and once the electrons are attracted by the sample, those will be detected by this secondary electron detector, and all this will be happened within this vacuum system only. That means it will be evacuated system. They will not be air because the electrons will not move properly in the air. It should be vacuum. A vacuum chamber will be there. In this vacuum chamber, those will be there. Okay, and the X-ray detector will be there. The X-ray detector, what happens so that the electron beam microscope should not be kept in the area wherein lot of the dense population is there. We are not going to keep it. Okay, the scanning, because there is a possibility that the X-rays will be leaked out and it will be entered into the human body and it will be dangerous. Okay, it will be having certain limitations. One has to take much more care about this electron beam microscope. Okay, the scanned electron beam microscope. Now, how the principally it is working? How principally it will be working? The scanning electron microscope, which will be focusing the electron beam over the surface of the image. Now, please remember, surface of the image I am telling you. Now here, simply I cannot take one sample and make the testing. It is not possible. A certain architect work we have to do before we go for the testing. A sample which has been selected should have to be prepared properly to suit with the requirement to test under the scanning electron microscope. Okay, it has to be etched and it has to be very shining, and a certain kind of buffing will be done so that the specimens are ready to test. Okay, the electron beam will be interacting with the sample. The electron beam will be interacting with the sample, and it will be producing the signals of various amplitude based on the surface topology and the composition of the surface. You can see that the electrons which will be liberated with what intensity after it is hitting over the specimen, which will be giving you the clear picture about the internal properties of the composition of the material and surface topology of the material. These electrons will be giving you the information. Okay, and this is what the secondary electrons and the back scanned electrons. Okay, there will be scattering of electrons. All the electrons which have been liberated from the cathode attracted towards the anode, those will not be exactly falling onto the surface of the workpiece. Certain electrons will be backscattered and those will be redirected once again, and some of them will be leaked out. Okay, and the secondary electrons which will be passing on them, these will be secondary electrons. Okay, now How this scanning electron microscope will be having the features, we'll see them. And the working principle of the scanning electron microscope will be totally different from the TEM, transmitted electron microscope. The transmitted electron microscope and the scanning electron microscope working principles will be slightly different. And you can see that the scanning electron microscope, the workpiece will be kept totally underneath in the vacuum space. You can see here, this is the workpiece. And this one, you can see that it is an electron gun, which will be called as the anode, sorry, the cathode. Okay, and this is the electron will be fired from here. Once it is heated up from the metal barrier, the electrons will be scattered, or those will be emitted from the cathode at a threshold temperature. And this particular space, the two indicates the main part of the machine wherein the traveling, it is a vacuum chamber. It is a vacuum chamber. It will be creating the vacuum chamber. And this will be called the positive charge electrode. This is an attractor. It is a energetic beam will be attracted from this. And the four will be called as the electromagnetic coil. This will be electromagnetic coil. And another one, this is another one coil. And in between them, there will be a series of lenses to redirect and focus these electron over the, close it and go over the surface of this. Okay. And what is this? Six indicate it is a systematic beam which will be falling onto this specimen after it is going through this magnetic coil and the lenses. What happens? A system with the scattered electrons. You can see in the beginning, the electrons will be scattered. These electrons scattered from the gun will be redirected by many coils in the lens, so that systematically these will be focused onto the specimen. Focused onto the specimen. This particular range is called the systematically arranged electron gun or electron beam. It will be focused onto the specimen, and this will be indicating this is the specimen. And please look here. Once the electron is bombarded onto the surface of this specimen, it will be redirected to other thing. It will be redirected, and both electrons will be attracted by this detector, and the electrons will be registered here. The scanned electrons will be registered here, and this will be turned into a picture. Please understand. The electrons will be registered at this particular detector, and these electrons will be registered here. Those will be turned into the picture. Those will be stored into picture of magnified level. It may be 1:1000, and even your normal photo, if you are going to make 1:10, you could not able to find out the faces properly because of the pixel quality will be very poor. Correct, no? So in the case of this electron beam, the scanning electron beam microscope, up to even 1000 times we can go for the magnification with a meaningful, intensive informations about the nanoparticles. That is what. And this one will be showing you the magnified image, which can be here with one thing. If it is a digital one, we can take the printout, and if it is another one, we can able to even display it on the TV. These are the main important parts of the scanning electron microscope. Please, once again, the scanning electron microscope, which will be totally different from the transmitted electron microscope. In this case, the narrow space, which will be totally vacuumated. That means there will not be air inside, and the specimen will be kept at the one end, and other end will be electron burn. The electron burn from the cathode will be emitted once after the threshold heating, and those will be scattered. And these scattered, this one, the electrodes, the electrons, okay, those will be attracted by the different lenses and the accelerators and the redirectors and all these will be arranged. You can see that the second, third, fourth, fifth, all this will be showing you the vacuumated space and the redirecting coils and the magnifying coils and the narrowing coils. So all these will be there. And once after that, systematically the electrons will be taken to the boundaries from the scatter position, and this density of the electrons will be falling onto the specimen. That will be called as the systematic scanning across the specimen. Once after, what is the meaning of scanning? Here the scanning means we are not going to move the workpiece or the specimen or the electrons. Please look here. Once the electrons which are directed over the surface of the specimen, those will be bounced back and those will be registered at the detector. The detector will register these electrons, and the registered electrons will be converted into, or those will be forming the picture of this particular specimen at the nano level. And the ninth one will be indicating directly we can able to even visualize by using the TV screen, or one can even take the printout by using the printer at the other end. This is about the scanning electron microscope. Okay. And what are the advantages and limitations of this scanning electron microscope? The scanning electron microscope will be very much useful for the three-dimensional details of an object and topographic images and some other informations in and around within the body. It is not transmitted, only it will be looking into a surface characters and it will be registering the electrons based on the surface roughness and the informations available on the surface of the specimen. Okay, and these are some of the advantages. Okay, and even it is magnified to a higher extent. What happens? The image which will be created by these bounced back electrons will be meaningful and it will be having very good resolution, so that we can able to find out the inner properties of the nanoparticles when they are been rearranged. That means when they have been synthesized, Okay. But what are the limitations or disadvantages? Advantages are, I told, we can able to even study the three-dimensional view of the object and topographic. That means the surface properties of the image we can able to find out. And apart from this, we can able to find out the versatile informations which are very much essential for the research work. The scanning electron microscope, to operate them, a proper trained person is required. Okay, and if you want to go for the getting the information about and store them into a computer, some kind of advanced computer technology has to be used along with the associated softwares. Those must be friendly enough for the operators. And you can see that every year once and company by company, there will be change in the software method or use of the software and procedure. So it will be creating a lot of confusions. As and when the technology will be changing and there will be implementation of the newer informations, it will be become very difficult for the programmers or the person who is going to do operation of this scanning electron microscope. So this is only the disadvantage, and here I see it is a disadvantage. It is not disadvantage. It is everybody's in the duty. Correct? No. Once there will be a change in the technology, one has to do the update, because this will be very much useful for the research work, research areas wherein the medicines, okay, and some body parts informations and some nanoparticles, as in case of nanophysics, like that, different applications. So the advantages we have seen the disadvantages also. And now limitations, we'll try to see them. The scanning electron microscope size is very big. The size of this will be very big and the cost also very high. And apart from this, the X-ray detector, as you know that, which will be finding each and every step, which will be detecting the X-rays which have been scattered from the electrons along with the electrons. Okay, that is one important thing. Okay, and this has to be kept in place wherein there should not be a magnetic field vibrations, or it should be free from all possible electric, the dangerous systems. Okay, it has to be kept there. And the maintenance of this the scanning electron microscope is slightly difficult. Okay, and electromagnetic coils will be there, and the circulation of cooling water is required because of it will be generating the heat. These are certain the limitations. And to operate the scanning electron microscope, one has to undergo the training. A trained person who can able to he can able to undergo the series of informations like those newer technology which is existing. They have to cope up with this, and they have to